Who's Albert Einstein?
One of the scientists.
Oh, he's actually, I mean, he's really good at math. He's a physicist, scientist. He was actually, I mean, he was good at math. Sure he was. But his math was so difficult, he used to ask mathematicians to help him do stuff because it was that hard. So Einstein somebody's talking to him and says, the quotient on the quantity 10 plus the number x is divided by 2. And he's saying, like, see what? He's trying to write this as an expression. So what should he be looking for here? What are strategies for Einstein to be able to write this as an expression? What are strategies you need? Figure out how to write this in that. Where'd you go? What would you do if you had to write this as math? Now I know how to get you quiet. I ask a question. Oh. Emma. Whoa, she's got the answer. Now how'd you get there? What did you look for here to help you come up with some kind of result? The way it was worded and the order. Were there any words in particular that caught your eye? Quotient. Okay, so one strategy. Let's take one word at a time. Awesome. So, quotient. You might want to circle these important words. Now, what does quotient mean? What does that mean? Division, right? What other words are we seeing? Quantity. Well, 10's a number. That's got to be important now. What else are we seeing, Matt? Plus. We know what that means, right? Now, what do you say? Is what? Is, but Greek verb is divided by. Is a tricky word to use as a key word because is does mean equal. He's absolutely right. Except it says is divided by. So is it meaning equal here? No. So we have to be careful to read the whole thing. We can't really read it necessarily in isolation. Is divided by is like quotient, sort of. Okay? And so she started putting it together. So let's see if we can figure this. Emma, do you want to say it again?
2 divided by 10 parentheses 10 plus x.
All right, 2 parentheses 10?
2 divided by 10 parentheses 10x.
Something like this? Okay.
You have a 10 in front of it.
No 10 in front of it. So you have 2 over 10x. So she's seeing quotient, she's seeing 10, and she's seeing x. Okay, that's a good first start. Oh, so you've got 2 over this. What do you think? Yeah, what do you think? Well, why did you put parentheses in? So it does it first. And was this word a clue to you to do that? Because that's what the word quantity means. You may not have seen that one before. Anybody else think this is right? Or have maybe a different way of looking at it? So let's see. The quotient. So when you divide, right, this quantity, 10 plus a number, and I like that you put it in parentheses, is divided by 2. So if something is divided by 2, do we write 2 over it or it over 2? Well, which is it? Is it this way? Is it the way she had it or this way? Well, let's see. Let's see what Einstein thinks. Now, he put it this way. How come? She was so close. I mean, that's pretty awesome. Why do we go the other way? Why do you think?
Because you put the answer, you'll see that one first. So you'll answer that, and then you'll divide it.
Okay. Yeah, Emma.
Because 10 plus x is either divided by 2 or not really divided by 10 plus x.
So you're saying 10 plus x is divided by 2. Let's use another number. Let's use something easy. 6 is divided by 2. What's that? 3. Well, you'll automatically know what to do, right? Yes. That was 6 over 2. Now it's something a little more complicated. It's 10 plus x divided by 2. So it's the thing that we are dividing by 2. So that's why it was this one. But she was awful close. So she read a lot of those clues correctly. Very nice. So I think you guys know a lot of this. So I'm going to assume you don't know a lot, so some of this will be easy peasy. I hope. So let's see. So if we're doing addition, subtraction, multiplication, division, we look for these word clues. So if you see these words, sum, plus, more than, increase by, usually that means addition. And why am I saying usually? Because Ben kind of showed us that if you just blindly memorize and don't think about it, it may be something else. Is does mean equal unless it means something else. You still have to really read it and make sense of it. So the sum of 2 and a number, how would I write that expression? Sum of 2 and a number? Yep. 2 plus x, right? So if hopefully you're following along the notes, you're writing that down. A number n plus 7, how would you write that? Yes, sir.
Oh, wait. Yeah.
And I said n plus 7. Now, are you wrong if you said 7 plus n?
No, because it's adding.
Right, addition has, what's the property that says you can add these numbers either way? Which property is that? Do you remember? Do you remember that? Commutative property. So you're not wrong if you said 7 plus n. However, if you're being a real stickler, a number n plus 7 strictly does become n plus 7. I would mark this wrong, but this is, I think, maybe slightly better. Now, it matters with subtraction, though. So the difference of a number n and 6. So difference less than minus decreased by. I'm using difference. How would I write the difference of a number n and 6? Yeah, what do you think? 6, right? Yes. Now, does the order matter here? What if we had said 6 minus n? Is that okay? No. So it is important to be very strictly reading it. If it says the difference of this and this, it's like we're going left to right, that's the order we write it. However, 5 less than a number y, what's that? Yeah, what is that? Okay, why are we turning it around? I just said don't turn it around. Why are we turning it around, Greta?
Saying 5 less, and then, like, we're going to take 5 away from y.
We're going to take 5 away from it. This one is the confusing one. Yeah, Matt?
She said that this is better
But why? She's absolutely right. Why? Yeah.
because you're saying that
Well, let me put it this way. If I said, my little sister is 5 years less than the age of her brother, and her brother is 10. She's 5 less than the age of her brother, what would you say? And he said, she's 5, right? You knew, intuitively, you knew to subtract it. So I find when some of these start getting confusing, because for some people this is like, you're good at memorizing. If somebody just said memorize it, I would not remember it the next day. I'm not good at memorizing. I need to know why. So give an example. Oh, somebody's 5 years less than a 10-year-old, they're 5. Right, you can see that kind of automatically. So put an easy example in sometimes. All right, multiplication, we're looking for times, product, multiplied by, and here's this word. Did you teach you last year? Teach you about of.
Nope.
Of means multiply. If you've never heard that before, write that on your paper somewhere. Of means multiply. Because it's very subtle in a word problem when you see of. Okay? Of means multiply. So what is 12 times the number y? Yeah, what is that? 12 times y. Now look how I wrote that. I wrote 12y. Now is it wrong if you wrote 12 times y? Is that wrong? No. Now is this wrong? 12 with a little x?
yes.
No. However, I am going to ask you not to use the x for times anymore. Why not? Why not?
That could be one of the variables.
Yeah, it gets confusing. It looks like a variable. So if you are doing a multiplication, you can use the dot. What's another way you can write this? You can use parentheses, right?
Yeah.
That's okay. You can use a star. Very computery. Use a star. But you don't need anything. If you've got a number and a variable, if there's no sign there, it is understood you are multiplying. So this is kind of the best in terms of shortcut. 12y. That's where we want to be. All right, look at this one. 1/3 of a number x. Yeah, what's that?
1/3 times x.
1/3 times x. And because I saw that word of, I know it's multiplication. Somebody took 1/3 of the 12 donuts. How many donuts did they take if they took 1/3 of 12 of them? Emily, 4. Of means multiply. Division, quotient divided by divided into. So we gotta be careful with that. The quotient of a number k and 2, what's that? What is that? K divided by 2. Now we have a few ways to write this. I wrote it as a fraction. Now you could write k divided by 2. It is correct. There's nothing wrong with that. When you start getting into higher math like you are right now, we tend to write fractions when we're talking about division. So we're going to have to get used to that. Okay, awesome. Quantity means parentheses. So 4 less than the quantity of 6 times the sum of the number and 5. What? Yeah, so I'm looking for my keywords here. 4 less than the quantity. So something is minus 4, right? Isn't that 4 less than? Something minus 4. What? The quantity of 6 times the sum of a number and 5. 6 times the sum of a number and 5. Whoa. So you gotta break this down. You gotta really break it down. What I do when I work on these is after I come up with it, I read it again. Is this 4 less than the quantity of 6 times the sum of a number and 5? Losers? Did I lose anybody? These ones are all complicated. Yeah. You take them a piece at a time. Quantity means there's parentheses. Right? This means minus 4. 6 times the sum of something. The sum of what? That's why I'm putting more parentheses in. A number, call it x, n, whatever you want to call it. And 5. So work on little pieces and put it together. Here's what I got. Yeah. Yep.
I did there's parentheses, x plus 5, then another parentheses, times 6.
Okay.
And then I minus 4.
Yeah, that's what I got, right? Good. So you really got to think about it. You got to think about them. Some of them can get a little complicated. All right, translating situations. The height of a wall that is 8 bricks tall if each brick is 3 inches tall. So I want you, how do you express this concept in math? So I'll tell you what I'm talking about. This might be a little hard to understand. I said 3D. So the height of a wall, we've got a wall. You want to know how high it is. It's B bricks tall. And each brick, so there's like B of these bricks, B of them, and they're 3 inches each. So that 3D represents that height. Let's see if we can do this one. The number of miles left to walk, if you need to walk 4 miles and you've already walked n miles, how many more do you have to go? What do you think? 4 minus n, right? 4 miles, you've already said done 1. Now with these, you can just put a number in. So let's say I've already walked 1 mile, and it's 4 miles total. I know I have to go 3 more miles. So when you put numbers in, sometimes it's easier to see what they are. The total number of lawns you will mow today, you've already mowed 4 lawns, and will mow W more of them? Oh my goodness gracious. What do you think? 4 plus W. When I said W plus 4, does that matter? I'm thinking I've already done, because I put a number in. Let's say you've already done 2 of them, and I have to do 4 more. I would probably say 2 plus 4, but it's okay if you said it the other way. All right, this one I think about. Each person share, if people share 3 gallons of water equally. Oh, what's this one of rhymes over here? What a mess, I think you are, right? Yeah. Okay, what is that?
3 divided by 2.
3 over 3? How do you know it's not this one?
Because it's the gallons that are getting divided between people.
That's the big thing, right?
Yeah.
Take them out. Another way to handle ones like this, because I think people get confused with this, he's absolutely right, is put a number in. Let's say you've had 3 people, and you have 3 gallons of water. What would they get? 1 gallon each. So that could go either way, but what if you had 2 people? They get, yeah, so what are you doing? You're dividing 3 by the number of people. Put in simple examples if you don't see it. The total width of a picture with its frame if the picture is 12 inches wide and the frame is X inches wide. Now, I have to make a picture, oh, I cannot do it. So I've got a picture with its frame, so what does that look like? Here's like maybe the frame and inside there's a picture, right? And I want to know the width, so something like this. The picture is 12 inches wide, right? And that's just from here to here. And the frame is X inches wide. But don't I have frame on either side? So what is this total width? Emma, what do you think? What is it? X plus 12? Right? Because I've got this piece, and I've got this piece, and I've got that piece. I keep saying the word and is plus. Now if I have an X and I have another X, how many X's do I have? 2 X's plus 12. So it's a little bit more complicated putting them together. Do we see that one? That was a little hard. Okay. Alrighty. So these are some new tries. I'm going to just give you a couple minutes. Do as many of these as you can, and then we'll talk about it. You think you have this one? No, Lara? Yeah, what'd you do?
I did input 12.
Hmm?
And parentheses of the X plus 12.
Because that's what? That's the quantity 12 more than a number X, right? So that's this. Okay.
And then I added another set of parentheses. And well, in that I did 50 divided by.
Right?
And then on the outside I did this.
Wow, awesome. And it's twice that quotient. So twice a quotient. I said twice a quotient of some kind. So I made a quotient. Of what? Of 50 and 12 more than a number X. You said 12 plus X. Is it wrong? Not really. But if you're, if you want to be exact, 12 more than is just like, it goes second. That was a hard one. How do we do on the rest? And we may not have gotten to all of them. How do we do with the number of days left in a week if D days have passed so far? Get that one? Because how many days are there in a week? 7. So it is depending on you knowing some common knowledge here. Any other questions on this? Okay, let's look at the other side. Right, we're on page 2. On the back here. So we've got some definitions, and these are things I think you know. When we talk about a mathematical open sentence, it's just a mathematical statement that has 2 or possibly more expressions in them, and a symbol that compares them. So examples of open sentences are equations and inequalities. So you have 2 expressions that have an equal sign, or 2 expressions that have less than equal, greater than, or greater than equal. Are we okay with knowing which one's less than and which one's greater than? Yeah? Yeah. All right, good. Okay, so what kind of open sentences are these? And I'm looking for something easy. Is it an equation or an inequality? So what's the first one? Yeah, what is that, Brenna? First one. Equation, right? Here's an expression, they're equal. What about this guy? Yeah, what is that one? Inequality. You may not have seen one like this. This is also an inequality. It's called a compound inequality. And it says y is greater than or equal to 7 and it's less than 25. Basically says y is between 7 and 25, but it also can be 7. So just identifying those. All right, so we need more word clues now when we're working with these open sentences. So equal to, the same as, and is. And as we saw, we have to be very careful with is. Is can sometimes be like is no more than. It's used to describe something else. But if you said, there it is 5 more than something else, that's an equal. Is less than, you might see fewer than. Less than or equal to. Now at most, I'm going to talk about that a little bit more. Is greater than, or sometimes we'll see more than. Is greater than or equal to, you will see at least. Now, does anybody get confused by that? That a less than is the word at most, and a greater than has the word at least. So we're going to try and really think about these so we don't confuse those again. So how would I write this in math. And I am, if you're following along, and hopefully you are, about 2/3 of the way down it says examples. The difference of twice the number and 8 is 12. What open sentence would I write? And tell me how you're getting it as well. So what would you write, Claire, and how are you getting it?
I would write x into 3 times 4.
Uh-huh. Okay, now you're correct. I wrote it like this. I used the k instead of x, that's fine. And this, there's nothing mathematically wrong with that. Why is my 2 turned around? I said 2 times k, and I didn't use any symbol. She said x times 2, right, with the symbol. What I don't want to see is x2 with no symbol. Don't do that, because that looks like x squared. Why am I kind of emphasizing that I want to see this? We're getting into algebra, you're in higher math, we just don't write that. You would always turn that around and say that's 2x. The number comes first and then the variable with no symbol in between. It's understood that's multiplication and subtraction, right? So we have to write a minus. 2k minus 8 equals 12, 2x minus 8 equals 12. That's what it looks like. So you're correct. I'm just making kind of, you may not be used to doing that. The product of 6 and a number is at least 24. So let's talk about this. So product is multiply, right? So 6 and a number, they didn't tell me what that is. So the product of 6 and a number, that's 6x, is at least 24. Now, when I see least, I want to put a less than. But I'm not. I'm going to think. First of all, if it's at least 24, can it be 24?
Yes.
So there's the equal that's going to go on the bottom. Now, at least 24. So can it be smaller than 24? Can it be bigger than 24? If you have to be at least 10 years old to ride some ride, and you're 11, can you ride it?
Yeah.
If you're 9, can you ride it?
No.
So what goes here, a greater than or a less than? Dan, what goes here?
Greater than or less
8
than.
greater than or equal to. 6, it's confusing. At least you're going to want to put a less than, but I want you to be out of autopilot. You know what I mean by that? Sometimes you just kind of react. I want you to really think, at least. So I can be it and I can be bigger. How about this one? I think I'm not going to do. I'm going to do just, I'm going to change this one. A number is no more than 13. A number is no more than 13. So I've got a number. It's no more than 13. Well, it can be 13, right? If you can go to this TV movie, if you're no more than 13 years old. So if you're 13, you can go, right? Can you go if you're older?
No.
But you can't go if you're younger. So these are kind of opposite than what we want it to be, but if you really think about what the words mean, they make sense. So out of autopilot and really, really thinking about it. All right, we're forgetting. We're almost done. How would we translate this? Yeah, you got it? Yeah, what is that?
B is less than or equal to.
Okay, so first of all, we have to deal with the quotient. The quotient of p and 12, so that's the quotient of p and 12, is at least 30. So we're going out of autopilot now. Can I be 30? If I'm at least 30, I can be 30.
Yes.
Is at least. Can I be smaller?
No.
So I can't be less, but can I be bigger?
Yes.
Greater than. So you've got to think, out of autopilot. Solutions, yeah, let's do this real quick. A solution to an open sentence is values that make the sentence true. You've been calling these answers. We're going to kind of get away from that. It's what makes the sentence true. So if I want to know if the number 3 is a solution, here's how you do it. And I am going to look at you following this process. Basically what you do is you substitute the 3 in, and is it true? So the first step will always be the substitution step. So write this down. So you have an example. Yeah, we're towards the bottom.
What was she?
I changed that one, so I crossed that one out a little bit. 8 minus 6. Notice I'm changing one thing. What's 8 minus 6? 2. What's my right side? 2. So I'm evaluating each side separately, and then when I'm done, number compared to number, if they match, I say yes, it is a solution.
Oh.
Okay, so this is what I want to see when I want you to verify a solution. Is 3 a solution to this? First step, plug it in. Now I'm just working this side. What's 4 times 3? 12. And now I'm looking at this side. Now you might see it right away. Yes, it is, no, it isn't. But you have to go number to number. What's 12 minus 5? Does that equal 6? Not a solution. Right? That's the process you follow if you want to know if something is a solution or not. With an inequality, you do the same thing, but you gotta be a little careful with it. 2 times 3 is 6. 11. Is 11 bigger than 12? No. Now let's try this one. Plugging it in. 5 plus 9. That's 14. Is 14 less than or equal to 20?
Yes.
Yes. So it doesn't necessarily have to be equal, it just has to match what the inequality symbol is. And I think we've all done this already, right? I don't think there was anything new in this whole thing, am I right? All right, so we have a couple of you tries. While you're working on that, I'm going to give you your homework.